G'day, Michael here. I've been asked just recently about overhangs and how I deal with overhangs with my print jobs. And there are, I guess there's three real points here. Let's see if I can keep them in some sort of sensible sequence. The suggestion was, why don't I call them parts? Well, I'm generally printing larger parts. This is about as small a part as I print, which that's about, I don't know, about 65 millimeters in height. And it's about 20 millimeters thick. That's basically my smallest part. And there's not much overhang. I tend to turn things in such a way that I don't produce an overhang, so I don't need to do any fill, etc. And I will actually change designs so that I don't have overhang. That's the first thing anyway. It's the simplest thing to do. But if I have got an overhang, which I actually do have a small amount of overhang in this. Focus. Where are we? I've got a little bit of a chamfer here, which doesn't, it kind of shows up there. I find 45 degrees is very easy to handle, and this is still hot on the bottom. It's on the platen basically. When I say hot, it's about 70 degrees. So the material has basically got to a point where it's sort of stiff, but not hard. Right, so that's one point. Basically avoiding designing in overhangs, if you can help it. And because I'm printing larger parts, I'm actually more struggling to keep a bit of warmth in the print, which brings me to my next point, and that is if there's anything I've learned about 3D printing, it's all about the layer you've just laid down. It's not about the layer you're printing, it's about the one that's already underneath. When you're on the platen, it's the condition of the platen ready for the first layer. When you're doing the second layer, it's actually the condition of the first layer that determines how your layer is going to perform. And that brings me to another point. I'm using larger tips simply to get material through. My smallest tip in the machine right now, as you can probably hear two of them printing right now, I'm running a 0.6mm tip and a 0.8mm tip. So I'm not using like a 0.2 for super high resolution. My aim is to get the product out. And so as a result, I've got wide tracks compared to other people. Now, I've done a little bit of a kind of simulation on my CAD program here. Let's see if this makes any sense. Okay, so here you can see the effect of like a smaller tip with the same 45 degree overhang, because basically what's coming out of that tip is, if it is left to its own devices, it's round. So here's a round thing. Let's say you had, I don't know, a 0.2 tip with a 0.2 layer height, right? So you'd actually have tracks that are laying down in such a way that don't connect. When you have a wider tip, that's, let's say it's a millimetre wide and that was 0.2 millimetres high, there's actually quite a lot of the track being supported by what's below it. So you can see, here's a very good example of mechanically having the layer below being designed better to support the next layer and also the layer you're laying down. So there would be a small amount of I'm going to say a sag on this track just here, which would blend down, but in essence it would hold quite nicely the laid down track. Here on the other hand, the tracks would just fall into open space, and so you need some sort of support. So basically, depending on what I'm printing, these particular parts here, I've got a 0.6mm tip doing this print, and I'm doing a 0.4mm track, layer height. If I was getting overhang, I'd probably drop that layer height down to maybe even 0.2, and then I can get away with quite a bit of unsupported print. And like I was saying, because I'm printing larger parts, I'm actually trying to keep the material warm so that it stays relaxed and flat on the platen until the print job's over. If I cool it too quickly, it'll shrink and give me tension problems. So I'm trying to, minimise the tension problems. If you're doing a small part with overhangs, you want the layer that's below it to set, which it won't really probably set. It's probably getting to the same sort of temperature as my larger parts are. So because it's much less time between it being laid down as a molten state versus its I'm going to say hardened state ready for the next track. So the small part is naturally going to stay hot. The layer below the active print is actually going to be hot when the next layer goes down, unless you cool it. With the larger prints, there's a lot of time between each track being laid down and the next one coming, so there is plenty of time to cool off. I think each layer on these particular prints I'm doing now, let's swing the camera around and have a look. Okay, in the Prusa, focus, In the Prusa I've got a fairly sizable part. It's about, I don't know, 140 by about 200, not quite, probably about 180, can't remember the numbers exactly. Anyhow, it's busily printing, and you can see there's a long time between layers. It's only doing a small part of that, but I guess it's probably going to be, I don't know, 3 or 4 minutes for this layer. So each layer is well and truly set by the time the next layer comes along. Now on the Black Widow, I've got 2 similar parts in there. Now, again, it's probably 10 minutes between layers because it's doing, 2 of them at the same time. So there's a lot of work cut out for these machines. Now that one there's got a 0.8mm tip, and this one's 0.6. My Delta's also got a 0.6. My Delta's actually the one that's most prone to having overhang problems, but generally, again, I'm printing larger parts. I pretty much exclusively print this particular part in the Delta. That thumps them out pretty quickly. And this one's printed out of ABS. So this is about as big as I can get an ABS part to behave itself reliably. And you can see there's height, and there's also a lot of print density here. Focus. Where are we? There's a fair bit of print density in there. I think the layer heights on this are 0.3mm, and it's a 0.6mm tip. So it's, it's nicely laid down. It dumps it out pretty quickly. I think this is about just shy of 70 grams of material. The actual print time is, probably, it's a 90-minute print job, but that includes warm-up, etc., etc. So it's probably about 60 minutes for 60 grams. But there's a lot of, how can I say, there's a lot of inactive print area on this. It's not a solid part. There's like honeycomb inside, which costs a lot of time without giving much weight. It's a lot of non-printing time. So I guess the active printing time, I'm guessing, it'd be something like about 40 minutes. So it's shoving through about 60 grams in 40 minutes. Yeah, and still producing, quite an acceptable print finish. Bigger parts. The concern is more keeping it warm. 3D printing is about the track you've just laid down, not the one you're on. And of course the physical geometry of the track width versus the layer height either works against you or in your favour for overhang. So they're the 3 elements I think are important. If you're doing small shapes, you need that part cooled down. If you're doing large shapes, the trouble is trying to keep it warm enough. Well, I guess that's it for me. Feel free to like, share, subscribe, ask a question, leave a comment. Bye for now.